All right, this is Ms. Cave with a lesson on additive relationships. You should have received this handout where you have a picture of a tree, you have a table, and then you have something that you're going to graph. I didn't mean to put that there. So you are going to look at the tree and tell me, what do you think this tree is? What is this a picture of? What is this a picture of? Miriam? A tree with a string on it. A tire swing. Yes, this is a tire swing. So let me tell you about the problem because it's not written on your paper. I'm going to tell you about the problem and then I'm going to give you time to try to figure it out. So what you have here is a tire swing, and this boy is making a tire swing, and he's trying to determine which branch he wants to use. Okay, so the X values here represent the branches, specifically how far the branch is from the ground. Okay, so this one, he wants to see if he uses a branch that's 5 feet from the ground versus a branch that's 7.5 feet from the ground versus a branch that's 11 feet from the ground. So he's trying to figure out which branch he wants to tie the rope to make his swing. Make sense? Okay, so that's what those numbers mean. Now, what he knows is he's going to need that amount of rope. He's going to need 5 feet of rope for a branch that's 5 feet. He's going to need 7.5 feet of rope for a branch that's 7.5 feet, or he's going to need 11 feet of rope for a branch that's 11 feet. Okay? And then he's actually going to add in a little bit more so it doesn't touch the ground, but we're not worried about that. So if he's using a piece of rope and he wants a 5 foot, if it's a 5 foot branch, or 5 feet from the branch to the tire, so this would be 5. So if this was 5, this distance right here, if he was trying to figure out how much rope he needs, is he just going to need exactly 5 feet? What? Is he just going to need 5 feet of rope to make it go around the tree and around the tire? No. Miriam? Yes, he needs rope not only for this distance. He doesn't only need 5 feet of rope, but he also needs rope so that he can tie. He's going to have to tie it here, and he's going to have to tie it to the tire. So he needs more than 5, and he's determined how much rope he'll need. And the amount of rope that he's going to need extra is 6 feet. He's going to need 6 feet of extra rope in order to make his swing work, because he needs the distance between the branch and the tire. Okay, that's your 5 for the first one, and he also needs 6 more feet to have enough rope. So what your job is right now is to determine how much rope he's going to need for various branches. So for 5, for 7.5, and for 11, you guys are going to fill in the table. And then I want you to go ahead and graph the information from the table here, and then we'll talk about it. So again, you're figuring out how much rope he needs. That's your Y. Your Y is going to be rope needed. And your X is going to be the amount of rope for that branch. So let's pause the video here. While you guys take time to figure this out, you can figure it out on your own and also talk within your groups. And when we're ready, we'll unpause the video and talk about what we came up with. All right, so now that you've had a chance to think about the problem, I just want to clarify a few things. First of all, the amount of rope is given. That's the branch. So for a branch that's 5 feet, you need 5 feet of rope. For a branch that's 7.5 feet, you need 7.5 feet of rope, so on and so forth. So this is the amount of rope that you need just to get this distance here. Okay, it's either 5, 7.5, he's looking at different X values, or 11. But we talked before how that amount of rope is not enough, right? Because he needs to also tie the rope. He's going to tie it right here. He's got to tie it to the branch, and he's also got to tie it to the tire itself. So he's going to need an additional 6 feet of rope no matter what branch he chooses. So with that being said, if he has a 5-foot branch, how much rope will he need in all? How many feet? 11, right? Because he needs to add 6 to our 11. And if he has 7.5 feet of rope, how much will he need in all? 13.5. And then for 11, he would need what? 17. So you have those numbers. They should be filled in on your table. So if you haven't already, go ahead and fill in those numbers now. And then what we're going to do is we're going to graph them. So I know the numbers are kind of difficult to see. Some of you have already started your graph, because we're going to look at the relationship between this additive relationship and a graph, as well as a word problem. So I'm going to go to my graph and I'm going to find 5. So down here, this is my branch length. And over here, this is how much rope I'm going to need. So I've got my branch and I have my rope. So for a 5-foot branch, okay, I'm going to go to 5. I'm going to go down here. For a 5-foot branch, I'm going to need 11 feet of rope. So I'm going to plot my point. For a 7.5 inch or 7.5 foot rope, I'm going to need, it tells me in the table, 13.5. So I'm going to graph 7.5, which is halfway between 7 and 8. And then I'm going to place my point right here in the middle. And then my third point is going to be 11 and 17. So 11 on the X. I'm going to go up to 17. So those are my 3 points that I graphed from the table. You have to count the numbers. Just count over to figure it out. You can just count. No, you can count it from your paper. Count it from your paper. You guys have the table values. So now that I have my coordinates, I'm going to go ahead and make a straight line between my coordinates, just like I did yesterday when I was finding my slope using slope. So if I connect those points, with a line, I've now graphed the function. Okay, I've graphed the situation. It's a straight line because for every 5 feet, or for 5 feet we have 11, for 7.5 feet we have 13.5, and for 11 feet we have 17. Now, is this relationship proportional? No. Tell me why how you know it's not proportional. Brandy. It doesn't go through the origin. So in order for a relationship to be proportional, it would have to go through the origin. And you guys can see that it doesn't go here through the origin. That's what proportional relationships are. This one is not proportional. It starts at what? Where does this graph start? 8. Not at 8. Count. 6. This graph starts at 0, 6. So whereas the other one started at 0, 0, this one starts at 0, 6. Big difference, right? So it's not proportional. So I can't just multiply the number of feet by anything, or the number of feet of the branch by anything to get the amount of rope. Instead of multiplying, what do I have to do? What did you have to do to each of the numbers? You did what? You added. So no matter what this was, you had to add 6. No matter what the branch height was, you added 6, the length of the extra rope, to get the total amount of rope. This is an example of an additive relationship because we're adding on each time. Additive relationships do not hit the origin, but they do form a straight line because there is a relationship. We're not going to say it doesn't matter. It does matter. Many relationships are additive and many are proportional. It depends on the situation. Okay? If we think back to the cookie problem, where Mary received 4 cookies to start with and 2 per day, we determined that that was not proportional. But do you remember who had the proportional relationship? Who got 2 cookies per day? Remember Alex? Alex got 2 cookies per day, so it was 2 cookies every day. For Alex's situation, and I'm just going to graph it here so we can see it. For Alex, so on day 0, Alex had 0 cookies. On day 1, he had 2. On day 2, he had 4. So we determined that that was a proportional relationship. In contrast now, we're looking at additive relationships, which are still very useful, and we're going to need to learn how to graph them, and that's what we've just done. So now that we've looked at this additive relationship with a tree branch, and you guys have an example of a table and a graph that is additive, not proportional, I'm going to show you another problem. So this is a problem about Suzanne, and Suzanne's cousin and her are racing. So Suzanne, thank you. I'll take one. Suzanne and her cousin are racing. Suzanne's cousin is faster than Suzanne. So if you know that someone is faster than you, what would you sometimes do? If you're racing like a little kid, what might you do for that kid to make it fair? Go slower, go faster. No. What would you do to make it fair? Who said head start? Okay, yeah, give them a head start. Okay, so that's the situation here. It says Suzanne's cousin gives her a 9-yard head start before they start racing. If Suzanne can run 1 yard per second, you're going to make a table of values, graph it, and give an equation that represents the total distance from the starting point that Suzanne has run based on the time that's elapsed. So on your paper, just to clarify, your time is going to be in seconds, so the number of seconds, and your distance is going to be in yards. And for this particular problem, I want you to start, I'm going to give you the time. These are your x values. After 0 seconds, after 1 second, after 2 seconds, and after 3 seconds. So you're going to determine the distance that Suzanne has run, or the distance that she is from her cousin, or no, distance she's run, based on the information that's given. And then you're going to graph it and try to come up with an equation. You can work within your groups, is fine, if you guys want to talk about it and try to figure out how to fill this in and graph it. So we're going to pause the video here, and then when we're ready to move on, we're going to unpause the video and talk about what you came up with for Susan and her cousin's race. Okay, now that we've had a chance to work on the problem, after 0 seconds, where would Suzanne be? What distance would Suzanne be at after 0 seconds? Farah? She'd be at 9 yards because, again, it tells us here that she has a 9-yard head start. So after 1 second, where would she be? What would her distance be? She was at 9, and it tells us that she can run 1 yard per second. Where is she going to be now? 10. After 2 seconds, where is she? 11. Then after 3, how many? 12. Okay? So let's look at the relationship between our x value and our y value. So what did you do to your x value, the time, to get the y value, the distance? What did you do? Added 9. Yes, so this is an additive relationship because each time another second passes by, we're adding 9. It works for all of these. 0 plus 9 is 9, 1 plus 9 is 10, 2 plus 9 is 11, and 3 plus 9 is 12. So when we're trying to think about what our equation is, y, 9, right, if I just want to plug this in, is equal to 0 plus 9. That's what I did to get that first value. For the second one, 10, which is our y value, is equal to 1 plus 9. So each time we added 9 to x to get y, and this is an additive relationship. So we can identify additive relationships by looking at our x and our y and figure out what's happening. If it's not proportional, if it's not multiplying, then for this unit, we're only looking at additive or multiplicative, okay? Now, next year, you guys will have equations where they're multiplying and adding things at the same time. And after the SOLs this year, we're going to go through and learn that, because I don't want you to assume that it's always additive or multiplicative. There is something else in between. But for our purposes, for this unit, we just need to be able to identify if there's a multiplicative relationship, proportional, or if it's additive. So if it's not multiplying, you know something's being added on or subtracted if it's a negative. Okay? So if I want to go and graph this, just like I did the other one, if I want to graph it, this down here is going to be my seconds. And then over here is going to be my distance. So after 0 seconds, she's gone 9, because that's her head start. After 1 second, she's gone 10 yards. And after 2 seconds, she's gone 11. And we can graph this like so. And we can see from the graph that this isn't proportional, right? How do I know it's not proportional? It doesn't go through the origin. Where does it go? Where does it start? At 9. It starts at 9. So this number, it starts at 9 because the graph starts at 9. Where a graph starts, it's called your y-intercept. That's the place where the graph starts, your y-intercept. When your y-intercept is 0, 0, you're not adding anything, you're just starting at 0. It's 0, okay? You're not adding anything. When it starts somewhere else, you're adding at that number, wherever it starts on the y. We're going to begin to connect this more. Right now, I want you to see the context, the real-life type problems that have an additive relationship. But when you guys see the video, I have a video for you guys to watch tomorrow, which has how you actually, if you have a table, a graph, how you actually pick out that y-intercept from different formats and then are able to write the equations. And it's a little, I think it's easier than we did slope. Now you might ask, well, what about this? Is there a slope? Does this line have a slope? Does the line have a slope? Is the line going up? Is it like a hill? It has a slope. What is the slope of this line? Because it's going up by how much each second? 1. So what's the slope? 1. So if I was writing this in an equation, look at this. This is algebra. Our equation, remember we did mx, y equals mx for proportional? Okay? And for any equation, it can be written y equals mx plus b. B is your y-intercept. That's your y-intercept. Okay? So my slope, rise over 1, is 1 over 1, right? So my slope is 1. So if I wanted to do my equation, it would be y equals 1x plus what? What are we adding each time? 9. So my equation, though, I don't need to write the 1. It would be y equals x plus 9. So there is a slope. It's just 1. For all of these additive relationships, the slope is going to be 1. That's all you're going to have to do for this particular unit. But in the future, just like Mary and her cookies, remember Mary started with 4? And then she had 2 cookies per day? So the y-intercept for Mary would be 4. That's where she started. That's what we added. And then 2 would be the slope. So that equation is y equals 2x plus 4. Okay? All right, we're going to look at one more task today. And this task involves downloading games. So you want to pass this out again? Thank you. So for this task, How many of you have downloaded a game on your phone before? Okay, so, all right, some people haven't. I've downloaded games. Okay, so when you download the game, do you have to pay for it? Sometimes you do, sometimes you don't. How many of you have downloaded a game that you don't have to pay for? Okay, but does it always end up being free? No. Sometimes when you download a game, they charge you for different levels. You ever had that happen? Or something that you need to add on to the game. Maybe you want a little different person, what's that called, avatar or something, and you want to change it, and they charge you money. Okay? Sometimes you buy a game, you pay for it, and then they charge you more money. That's what's frustrating, right? Because you paid for the game, and then you want to get up different levels. Like as you improve at the game, they actually charge you more money. So that's what this problem is about. So if you take a look up here, it says an iPad game. People still have iPads, right? No. No? Okay, iPhone game. People do. That's not true. Okay. An iPad game will cost $3 to download. So this is an example of a game. If I want to download a game, it's $3. But not only that, it says in order to increase the levels within the game, you'll be charged $1 per level. So it's not just the $3 to download, you're also going to be charged $1 per level. So what you're going to do is you're going to figure out, based on how many levels you've purchased, what the total cost is. So again, it's $3 to download. That's for no levels at all. Maybe I'm starting at level 1. But if I want to purchase an additional level, I'm going to have to pay another $1. So what I want you guys to do is to fill in this table, think about what the question is asking, and fill in the table to find the total cost, determine whether it's proportional or not, and explain how you know. I want you to graph the information, and then think about, this is a good question too, I want you guys to answer. Should the points be connected? So should the points be connected? That's something we need to think about and talk about. And then the other questions you're going to answer about the graph. So we're going to do this, and then the last thing you're going to do is on the other side, you have another equation. So for this equation, there's nothing given. There's no information. It's just telling you y equals x minus 4. I want you to graph that here. Okay, see if you can graph it. See if you can graph x minus 4. I'll give you a hint. Make a table. Make a table. Make a table of values and plug in different values for x. So I'll even give you the first few. If we use 0, 1, and 2 for x, figure out what y would be. And then plug those values in to the table and then graph them. And then see if you can come up with the y-intercept. So this is actually applying everything that we need to know about y-intercept, because we started with a verbal description, the video game problem, right? We have a table that we're filling in, we're graphing it, and we're coming up with an equation. So this is everything that we're going to do. Just like when we started out with the cookie problem, it was everything we're going to do in the unit. Now we're kind of zeroing in on y-intercept problems, additive relationships, where we spent a whole lot of time on proportional. We're not going to spend nearly as much time on additive as we did proportional. Okay, because we already know how to find slope. All right, so you guys have the rest of the time to complete this, and you can work together, and then we'll either go over it today or possibly tomorrow. And that's it for our lesson on y-intercept.